Up to 35% of Basque people have Rh-negative blood. And Rh-negative blood is one of the most unusual blood types.
Grok AI just analyzed Rh-negative blood, and what it uncovered raises questions most people never think to ask. This isn't just about a rare blood type, it's about patterns that don't seem to follow the rules. Why does this trait appear more in certain groups? And what does that say about where it came from? One detail, hidden inside global data, stands out in a way experts didn't expect. It connects history, biology, and something deeper. But the real surprise isn't what you think, it's what that pattern might actually mean. The mystery of Rh-negative blood. Rh-negative blood is one of the most intriguing mysteries in human biology. Unlike the more common Rh-positive type, people with Rh-negative blood lack the Rh factor, a protein found on red blood cells. On its own, this difference usually causes no harm, but in certain situations, especially pregnancy or blood transfusions, it can lead to serious complications that have puzzled doctors for decades. What makes this blood type even more fascinating is how unevenly it appears around the world. Roughly 15% of people are Rh negative, but in some populations, the percentage is much higher. This unusual pattern suggests that the trait didn't spread evenly through human history. Instead, it may have been preserved within specific groups, shaped by isolation, migration, and time. The mystery becomes more personal when it affects families. An Rh-negative mother carrying an Rh-positive baby can face a dangerous immune reaction. Her body may recognize the baby's blood as foreign and produce antibodies against it. Before modern medicine understood this condition, many pregnancies ended in tragedy, with no clear explanation for what went wrong. Scientists have spent years trying to uncover where this rare blood type came from and why it persists. Genetic studies show that Rh-negative individuals often carry distinct markers, hinting at ancient origins tied to isolated populations. These clues suggest that this trait is more than just a biological variation. It may be a living remnant of humanity's distant past. Yet despite all the research, the full story remains incomplete. Rh-negative blood continues to raise questions about evolution, survival, and the hidden pathways of human history. It's a small difference in our biology, but one that carries a surprisingly deep and unresolved story. Rh-negative blood presents challenges for scientists, while it provides information about how humans survive and adapt to different environments. The blood type's immune system characteristics enabled certain populations to survive through difficult times, which included environmental disasters and disease outbreaks. The gene maintained itself through time because these minor benefits allowed the gene to survive despite its dangers for expectant mothers. The understanding of evolutionary dynamics enables researchers to solve this complex biological problem. The medical field has undergone a complete transformation because of its advancements, which have created new opportunities for treating Rh-negative blood. Scientists develop treatments that save lives by studying this blood type, which now allows doctors to prevent immune reactions in pregnant patients who have previously mysterious conditions. This progress is not just a scientific achievement, but a profound story of how knowledge transforms human lives and hopes. The origins of Rh-negative blood remain an enduring mystery that researchers from all over the world continue to investigate. The search for answers continues through cutting-edge genetic research and the study of ancient human remains. Scientists use DNA analysis from ancient bones and various populations to trace the historical development of Rh-negative blood. Each discovery brings new possibilities to transform our knowledge about ancestral relationships and unexpected genetic links. Scientists continue to study Rh-negative blood because they have not yet discovered its complete history. The blood type's rarity and difficulty of identification serve as more than biological features because they help researchers understand how ancient humans moved between regions and maintained their cultural identity. Scientific progress will lead to the discovery of all hidden mysteries which exist within our blood. Across time and place, one group stands out as a living clue to this enigma: the Basque Connection. Nestled between the Atlantic coast of France and the towering Pyrenees Mountains of Spain lies the Basque region, home to a people like no other in Europe. The Basque have long captivated scientists because of their distinct cultural, linguistic, and genetic identity. One of their most remarkable traits is the unusually high percentage of Rh-negative blood found among them, up to 35%, more than double the global average. This sharp contrast makes the Basque people a key to understanding the mystery of this rare blood type. The Basque also speak a language called Euskara, which is unrelated to any other known language in the world. This linguistic uniqueness suggests that they are descendants of some of Europe's earliest inhabitants, living almost untouched by the waves of migration and cultural blending that shaped the continent. Their genes support this idea. Basque DNA reveals little mixing with later European populations, preserving a genetic heritage that dates back thousands of years to hunter-gatherer communities predating farming and civilization. What makes the Basque truly fascinating to researchers is how closely their genetic makeup connects to ancient populations who lived during the Paleolithic era. Studies show that they carry rare genetic markers, including a high prevalence of blood type O and, notably, Rh-negative blood, a link that points to a time before modern societies. Investigating these traits offers a glimpse into a world frozen in time within their isolated mountain valleys, making the Basque people one of the last living connections to Europe's deep past. Scientists believe that the high occurrence of Rh-negative blood among the Basque might be a result of genetic isolation, which their community maintained through endogamy for many years. Their remote and rugged homelands helped shield them from widespread genetic mixing. Their geographic and cultural isolation enabled their bloodlines and languages to survive, while all others disappeared. The Basque population shows genetic differences which are combined with physical characteristics that some researchers trace back to ancient European ancestry. The Basque people possess physical features which display their connection to Europe's first inhabitants, although these traits might also stem from their mountain climbing challenges. The Basque people possess multiple attributes which challenge traditional understandings of European genetic ancestry. The Basque people contain mysterious elements which exist beyond the field of anthropology because they extend into medical science. The study of Rh-negative blood frequency in this region brings advantages because it helps to reveal genetic ancestry while showing how this blood group affects health and reproductive abilities. The Basque population serves as a research site to investigate how Rh-negative blood distribution and genetic transmission occur within their community, which lacks outside genetic material. Their story raises profound questions about the genetic uniqueness of the Basque people, which might provide information about the original source of Rh-negative blood. Does their preserved lineage trace back to encounters with ancient human species? Their genetic makeup, together with their cultural practices, contains answers which will enhance our comprehension of human origins. The Basque puzzle sets the stage for a theory that reaches even further back into time than the Paleolithic, hinting at humanity's tangled relationship with other early human species, ancient roots, and Neanderthal links. the origins of Rh-negative blood may reach deeper into human history than we once imagined, possibly even to our ancient cousins, the Neanderthals. Long before modern humans spread across Europe, Neanderthals lived and adapted to harsh Ice Age environments. Today, genetic evidence shows that many people still carry small traces of their DNA, proving that our species once interbred tens of thousands of years ago. This discovery has led scientists to ask a bold question. Could the Rh-negative blood type be one of those ancient inheritances? The idea is especially intriguing in regions like the Iberian Peninsula, where early human populations, including the ancestors of the Basques, lived in relative isolation. Some researchers suggest that small Neanderthal groups may have overlapped with modern humans there, allowing rare genetic traits to pass between species. However, the evidence remains uncertain. So far, recovered Neanderthal DNA has not definitively shown the Rh-negative gene. That gap keeps the theory unproven, but not dismissed. Scientists continue to explore it because Rh-negative blood is unevenly distributed, appearing more frequently in specific populations, like the Basques. Explaining that pattern requires looking at both ancient interactions and later population dynamics. One of those dynamics is genetic drift. During the Ice Age, much of Europe was covered in glaciers, forcing human groups into isolated refugees. In places like the Iberian Peninsula, small communities lived with limited outside contact. Over generations, certain traits, including Rh-negative blood, could become more common simply by chance, reinforced by intermarriage within the group. There's also the possibility of a survival advantage. Some researchers believe Rh-negative blood may influence immune responses in subtle ways, potentially offering protection against certain diseases or environmental stresses. In extreme conditions, even a small advantage could help a trait persist, despite the reproductive risks associated with Rh incompatibility. What makes this story compelling is how these layers connect. Ancient interbreeding, isolation, and environmental pressure may have all played a role in preserving this rare blood type. Each theory adds another piece to the puzzle, revealing how human evolution is shaped not by a single cause, but by overlapping forces across time. In the end, negative blood remains a mystery, but not an empty one. It carries echoes of ancient encounters, survival in harsh climates, and the quiet influence of genetics over generations. More than a medical trait, it's a living trace of where we came from and how deeply our past still flows within us. From these ancient threads, a modern medical challenge emerged, testing human ingenuity in new and vital ways. Medical risks and Rh disease. The rarity of Rh-negative blood comes with a hidden danger, especially for women during pregnancy. When a mother with Rh-negative blood carries a baby with Rh-positive blood, often inherited from the father, her immune system can see the baby's blood as foreign and mount an attack. This immune response produces antibodies designed to destroy Rh-positive red blood cells, leading to a condition known as hemolytic disease of the newborn. Without intervention, this can cause serious health problems for the baby, including anemia, jaundice, brain damage, or even stillbirth. For many years, doctors struggled to explain why some women had healthy first pregnancies, only to suffer tragic losses afterward. These repeated heartbreaks puzzled families and physicians alike, and the cause remained a deeply frustrating mystery. It wasn't until 1939 that this condition was officially recognized and named Rh disease, bringing new focus to research into its mechanisms and prevention. However, understanding was still limited, and no effective treatment existed at the time to protect at-risk pregnancies. The problem arose from the mother's immune system sensitizing to Rh-positive blood during childbirth or trauma, such as a fall or injury, when the baby's blood mixes with the mother's bloodstream. Once sensitized, her body produces antibodies that attack any Rh-positive red blood cells in future pregnancies, making subsequent babies vulnerable. This sensitization process explained why losses often occurred after the first child. Yet, it took decades of research to develop ways to prevent this destructive immune reaction. Before a breakthrough, families enduring Rh disease faced a cycle of joy and sorrow with little hope. Babies born healthy one time could be gravely sick or lost the next without warning. Medical professionals had no tools to intervene, which made the condition feel like an unavoidable tragedy. Many parents suffered silently, haunted by an inexplicable pattern of loss that science had yet to solve. The mid-20th century saw increased research about Rh disease when newspapers started showing their expectations for finding a cure. Scientists understood that stopping the mother's immune response could save babies' lives, but the method to achieve this goal remained unknown. The task involved finding ways to block antibody production without causing harm to both the mother and her child. The research required researchers to explore new medical fields through development of new ideas and untested approaches. Scientists made a significant breakthrough when they discovered that antibodies themselves might provide the solution to their problem. A young doctor named John Gorman theorized that injecting mothers with special antibodies soon after childbirth could trick their immune systems into accepting Rh-positive blood as harmless. This novel method provided protective antibodies before the body could develop a reaction to prevent sensitization from occurring. The straightforward nature of this concept required extensive testing for validation purposes, which included safety assessment and efficacy evaluation. Gorman and obstetrician Vincent Frieda created a testing plan to assess their hypothesis. The researchers conducted groundbreaking research by administering antibodies, which became Rh immunoglobulin, to Rh-negative mothers who had just given birth to Rh-positive babies. The researchers aimed to prevent the immune system from creating dangerous antibodies which cause Rh disease. The new medical approach brought about a significant change to obstetric medicine, which enabled doctors to protect unborn children from serious medical problems. The transition from theoretical concepts to practical applications encountered difficulties, but ultimately achieved success. The testing process required extensive clinical trials, which included testing volunteers in unusual environments to assess treatment impacts. Medical professionals accepted Rh immunoglobulin injection as the standard treatment after its successful validation. Medical personnel administer the procedure within 3 days after childbirth, or any incident which allows fetal blood to enter maternal circulation, and this approach effectively diminishes the chances of Rh disease. The quick administration of this basic injection transformed the pregnancy experience for Rh-negative women because it turned their previous high-risk status into a controllable medical situation. The success of this medical breakthrough paved the way for a profound shift in prenatal care and opened doors for further advancements in understanding blood compatibility. The breakthrough discovery. The defeat of Rh disease is one of medicine's most powerful quiet victories, a story built on observation, persistence, and a refusal to accept unexplained loss. It began in the early 20th century, when scientists first realized that human blood isn't the same for everyone. The work of Karl Landsteiner revealed that blood is divided into types, laying the foundation for understanding why some pregnancies turn dangerous without warning. Years later, Philip Levine connected the missing piece. In 1941, he identified the link between the Rh factor and a deadly condition affecting newborns. His research showed that when an Rh-negative mother carries an Rh-positive baby, her immune system can treat the baby's blood as a threat. The first pregnancy often passes safely, but the mother becomes sensitized, meaning future pregnancies are at risk, as her body produces antibodies that can attack the baby's red blood cells. This insight changed everything. For the first time, doctors could predict which pregnancies were in danger instead of reacting too late. But understanding the problem wasn't enough. The real challenge was preventing it. That breakthrough came through the work of John Gorman and Vincent Frieda in the late 1950s and early 1960s. They developed Rh immunoglobulin, a treatment designed to stop the mother's immune system before it could become sensitized. By giving this injection after childbirth or any blood exposure, the body is essentially tricked into ignoring Rh-positive cells. The idea was bold, and it worked. Early trials, including studies conducted in places like Sing Sing Correctional Facility, proved the treatment's safety and effectiveness. By the 1960s, it became standard practice, dramatically reducing cases of Rh disease and saving countless lives. Today, Rh immunoglobulin is a routine part of prenatal care. What was once a mysterious and often fatal condition is now largely preventable, and behind that success is a simple truth. Careful observation, scientific courage, and compassion can turn even the most devastating medical mysteries into something we can control. With this life-saving discovery secured, new questions about Rh-negative blood's origins and persistence come into focus, inviting us to explore why this rare trait endures in the human family. Why has Rh-negative blood survived despite its risks during pregnancy? It's a question that has puzzled scientists for decades. One explanation lies in genetic drift, where rare traits become common in small, isolated populations simply by chance. Groups like the Basques, who lived with limited outside contact, may have preserved this trait across generations, allowing it to quietly endure while the rest of the world changed. History also played a role. During the Ice Age, human populations were pushed into isolated refuges like the Iberian Peninsula. In these small, separated communities, certain genes, including Rh-negative, had a higher chance of being passed down repeatedly. With less intermixing, ancient genetic traits were not diluted, but reinforced. The process of survival requires more than random luck to achieve success. Some researchers believe that Rh-negative blood provides people with hidden benefits. The absence of the Rh protein could influence immune responses, which might help carriers of the mutation develop stronger protection against specific illnesses. The minor benefit which people gained from the advantage of Rh incompatibility during extreme situations, which existed during those times, proved to be more beneficial than the dangers which came from their inability to reproduce. The situation contains a hidden element which remains unknown. Some theories suggest the Rh-negative trait may trace back to ancient interbreeding with Neanderthals. The blood type remains unproven, but this discovery adds new information which shows that this blood type serves as a genetic trace from ancient time periods when humans interacted with one another. The risk and survival aspects of Rh-negative blood create an intriguing characteristic about this blood type. The blood type continues to exist in society because of its medical significance, which extends beyond being a simple health fact. The discovery serves as a living historical record, which shows how human history Migration patterns and evolutionary processes have become embedded in our DNA. Rh-negative blood is a rare and fascinating thread woven through our ancient past, medical breakthroughs, and human survival stories. From the Basque people's genetic legacy to life-saving advanced, Grok AI just analyzed Rh-negative blood, and what it uncovered raises questions most people never think to ask. This isn't just about a rare blood type, it's about patterns that don't seem to follow the rules.